Good morning, students. Welcome back. I hope you all are fit and fine and found innovative ways to enjoy yourself during the vacations and had a good time. I also hope that you have revised all the previous chapters and topics that we have covered so far in science. Today we will start a new chapter called Separation of Substances. So let us begin. Before we start the chapter, let us recap certain topics that we have covered. Matter is anything that has mass and occupies space. It is of three types: solid, liquid, and gas. Matter is broadly classified into two types: mixtures and pure substances. Mixtures have variable compositions and are of two types: heterogeneous and homogeneous. Pure substances have a constant composition and they are of two types: elements and compounds. But what are pure substances? Does it mean a substance that is having no impurity? Let us find out. Pure substances have only one kind of material. That means they are made up of the same kind of atoms and they have fixed melting point or boiling point. Let us see some examples of pure substances. So, a pure substance is matter that has definite chemical and physical properties. It is made up of only one kind of particles. So, an aluminium foil is made up of only aluminium atoms or molecules. Similarly, sugar is made up of only sugar molecules. Pure substances come in two types: elements and compounds. Elements are of many types like gold, silver, copper, iron, oxygen, hydrogen, carbon, etc. Compounds are also of many types like water, carbon dioxide, sugar, and salt. An element is a pure substance that is made up of only one kind of atom. All the matter around us is made up of one element or a combination of elements. Elements are usually organized on a chart called the periodic table. Compound is a pure substance which is made up of two or more elements that have chemically combined with each other. So it is a little difficult to separate out a compound. For example, water is a compound. It is made up of two atoms of hydrogen and one atom of oxygen. Mixtures contain two or more pure substances that are just mixed together. They are not chemically combined. Mixtures can mix pure substances, compounds, or both. So they are of two types: homogeneous and heterogeneous. So mixtures are the physical combinations of two or more pure substances, like tap water. Tap water has water and many salts dissolved inside it, so it is a mixture. But distilled water is a pure substance because it contains only one kind of particle. So water becomes a pure substance, whereas materials like sand is a mixture. Water has only hydrogen and oxygen, which is chemically combined with each other. But sand is a mixture of many things. For example, if we bake a cake, we need many ingredients like eggs, sugar, oil, flour, etc. So cake is a mixture of many ingredients. Hence, it is not an element or compound but a mixture. Similarly, seawater. Distilled water is of course a compound because it is made up of only hydrogen and oxygen, which is chemically combined. But seawater is a mixture of many salts which are dissolved in water. So it is not a compound anymore, it becomes a mixture. There are mainly two types of mixtures, homogeneous and heterogeneous. A homogeneous mixture is that which has the same composition throughout. So we cannot distinguish the different things that make up a mixture. Like if you add salt and water. When the salt completely mixes with water, we can no longer see the salt. Hence it is homogeneous. But soil is a heterogeneous mixture. Because in soil we can see the different particles that are added together. So it is no longer a homogeneous mixture. But a fruit juice which is made up of only one type of fruit is a homogeneous mixture because we cannot see the different things that are mixed together inside the fruit juice. So even if you add a little bit of sugar and salt inside it and try to dissolve it, it will completely disappear. So we cannot see the different particles or substances which are mixed inside a mixture. Air is also a homogeneous mixture of many gases. Carbon dioxide, water vapor, oxygen, hydrogen, helium and argon are completely mixed with each other and they are not visible to us. So we say that air is a homogeneous mixture. So in a homogeneous mixture, we cannot distinguish the components. So examples are like vegetable puree, when we mix it completely in the grinder, it will form a homogeneous mixture. Similarly, a cup of coffee, a glass of milkshake or orange juice, tomato soup and chocolates. They look like they are made up of only one type of material, but actually they are a mixture of many things mixed together. We just cannot see them. In a heterogeneous mixture, we can see and distinguish all the components of a mixture. Like in a salad or a fruit salad, chickpea salad or milk and cereals. So we can clearly see the different parts of a mixture. The different parts of a mixture are called the components of a mixture. So we can easily see and distinguish the components in a heterogeneous mixture, but not in a homogeneous mixture. A solution is a name of homogeneous mixture that is so well mixed that we can no longer see the different substances. So solution is also called a homogeneous mixture. It has got mainly two parts, the solvent and the solute. Solvent is what you have the most of. That is what you dissolve another substance in. For example, if we are dissolving some sugar in a glass of iced tea, the iced tea becomes a solvent because we have more tea than the sugar. Whereas a solute is a solution in which is having the least of. That means the substance that is getting dissolved inside a solvent. So in a iced tea, the sugar is the solute because we have much less sugar than the iced tea. So solubility is a measure of how well a solute can dissolve in a solvent at a given temperature. The solubility tells us how much of it you can add before it will not be able to dissolve any more. Whereas a substance is insoluble if it cannot dissolve in a particular solvent. We all know that sand is insoluble in water. So it will not ever dissolve inside the solution no matter how much you stir in the sand.